Hey everybody, welcome to 7.5 part 2. So we're going to continue working on our square root and cube root graphs. And on this side we're going to continue to work on translating, but now we're also going to have a stretch or a compression with our movement. So one other thing I want to tell you is they're not always going to have it in square root form, because a 1/2 exponent is the same thing as a square root. What they've given us for example C is really the -3 times the square root of x plus 3 in disguise. So if it helps you out, just rewrite it first, then try to graph it. And now I just want to point out as well that I only put the square root around the x because that was the only thing that it was with, because there's no parentheses. But in this situation, whatever is in the parentheses goes underneath the square root. Alright, so when I start out this way, I'm going to start out the same way we did examples A and B. So I'm going to graph my parent function, and this never ever changes because every single time we're graphing the graph y equals square root of x. And again, we picked these 3 points because they're specific dots that are easy to move. So every single time I'm starting out with my parent function. Now, to do this graph, the first time I teach you this, I'm actually going to teach it in 2 steps, but when you get the hang of it later, it's okay if you do this all in the same step. So here's what I'm going to do. I'm going to actually first graph the stretch before I move my graph. And the stretch or compression comes from that a value, the a value that's in front of the square root. So right now, it's a -3. So here's what I got to imagine. Normally my graph was 0, 0, 1, 1, 4, 2. That's just 3 of the points on my parent function. What happens here is that now I'm putting a -3 in front of the answer, so each one of these basically is multiplied by -3. So now that's still 0, that's now -3, that's now -6. So 0, 0 is going to stay where it's at. The next point goes down to 1, 2, -3 instead, and then the third point goes down all the way down to -6. So this is my graph right now. I'm just in the intermediary step though. I'm not at my final graph yet. But I just want to pause a second and make sure that this makes sense. Sometimes students don't really use a chart. One thing you can think about is that number in front, it's kind of like slope. There's technically not a slope for a square root graph, but if you want to think about it like a slope, that's a good way to think of it. So instead of having, this would be maybe my normal slope, and now instead of going up to 1, I'm going to go down to 3, and then instead of up to 2, I'm going down to -6. So basically what I've done is I've taken the y value of each of these and multiplied by -3. So you multiply the y value by -3. Hopefully after example D and then a few more with the cubed root, that'll become more clear to you. Now that I've graphed the stretch, I'm going to, in step 2, graph the translation. And when I say translation, I mean up, down, left, right. So at this part, you guys are pretty good at this by this stage. I look at this, it has a plus sign, it's outside the square root, so in my mind I'm thinking up 3. So that green graph we just created, I'm going to take each one of those points and move it up 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. And then that, in the red, is my final answer. So again, like I said before, these intermediary steps are actually not required. Only the final answer is what you need to get full credit. So if you want to cut out one of the steps or both of the steps, you can. But if you're someone who's struggling, I would recommend that you do all 3 steps to get your graph. We need to do domain and range for this. And if I look at this, remember I'm looking at where my x's and y's go. So this time my x values are starting right here, so that actually hasn't moved left or right at all. So the domain is the same as normal. But the range has moved. The range, it's moved up 3. And then also, it's not going above the line right now, it's going below. So it's not actually values larger than 3, now it's values below 3. So I'm going to say y is less than or equal to 3. Notice how this is not anything that we've done yet before, so that's new. Now it's less than instead of greater than. Alright, for example D, I'm going to do the same process. So step 1, I'm going to graph my parent function. 0, 0, 1, 1, and 4, 2 are the 3 critical points for my parent function. I am going to first graph the stretch or compression. In this situation, I've got a 2 in front. So again, remember how I said you only multiply the y values? Basically, all of the y values get multiplied by 2. And for a lot of you, it might be more clear when we're starting out here if I put it in chart format. So again, here is my parent function. What's happening is I'm just putting a 2 right in front of that square root. So everything I had for my answer before now becomes times 2. And these are my new y values. So again, the x values stay the same, just the y values change. So it still starts at 0, 0, but instead of going up to 1, it goes up to 2. And at the next point, instead of going up to 2, it goes all the way up to 4. And I have not done any of the translations yet. All I did is the 2 in front of the square root of x. Alright, now that I've done that, now let's move it. So, I'm looking at my up, down, left, right, and I gotta consider what's happening here. When I look at this, looking back at my notes if needed, I'm thinking it's going right 1 and up 1. That's easy, so I'm going to take all my green dots and go right 1, up 1, right 1, up 1. And draw on my new graph. And so this is my answer graph. And we will find the domain or range again. So, finding the domain and range, remember, basing it off of where the red graph starts. So my domain, this situation, my x value did shift over, so now my x is greater than or equal to 1, and for my range, that also moved up 1, so and it's above the line, so its value is greater than or equal to 1 for that range. Please pause the video and make sure you get all that down. Sorry, I'll scroll up for a second. And then when you're ready, we'll move on to the cube root graphs. And we will do lots of practice graphs in class in case you're wondering, because for a lot of you, 2 examples of the tricky ones might not be enough. Let's move on to the cube root graph and we'll see what happens with that. Alright, so again, I've got a parent function that I'm going to translate. And now for the cube root graph, we had put a bunch of different points on our sheet. Flip over to the front quick if you want to look at our parent function. Again, I want to pick some critical points that are going to be easy to graph and translate. And when I look at the cube root graph, the ones that are the easiest to graph and translate are 0, 0, 1, 1, and -1, -1. All the rest of them are decimals. So just these 3 points I'm going to use for my parent function every single time. So your answer graph will also just have those 3 points just moved or stretched out. So that is my parent function. And now, remember, same rules apply. So if it's outside the square root or cube root, it's up or down. If it's inside the square root or cube root, it's left or right. So I've got an outside 4, and it's positive, so I'm thinking up. And that means each of the dots I decided to use from my parent function, remember, it's the same graph on the front, I just didn't graph all the points. I'm going to move each of those up 4. Alright, here I go. I'm moving each of them up 4 and graphing in my new graph. And that's it for my answer for that, and then we got to do domain and range. So, you may or may not remember this from the front of the page, but remember how I said for a cube root graph, the domain and range are actually always going to be all real numbers. The reason is, if you look at what's happening here, there's no starting or stopping point for the x's or the y's. So notice there's no like definitive point where I can say this is where the graph starts. No, it's infinite. It's going in either direction to infinity, and also it's going up very slowly, but eventually it's going up and down to infinity as well. So what that means is the domain and range are going to be all real numbers, and even though the graph is shifted, it's still all real numbers for the domain and range, because there's an infinite amount before and still an infinite amount. Alright, why don't you pause and try F on your own quick. If you have unpaused and you're now watching, here is me graphing in my parent function. Again, I'm using -1, -1, 0, 0, 1, 1. There's my parent function. And I hope that you identified this time, this is underneath the square root, so I'm going left 4 this time. Alright, so every point is moved 1, 2, 3, 4 units to the left. Here I go. There is my answer graph. And again, you don't it's not required to graph the parent function, that's optional. And like I said before, domain and range are going to be all reals for any cubed root graph because it's going to infinity in both directions. Alright, now we have the joy of doing the ones with a stretch or compression. And again, I want to tell you that they're going to try to trick you, but you won't be tricked because you guys know this. If it has a 1/3 power, it's really the same thing as a cubed root, so don't let that throw you off. Alright, like we did before, I'm going to do the stretch first, and then we will do the up, down, left, right shift. So I will start by graphing my parent function. And it's even easier to do a stretch and shift with a cubed root graph actually. So here's what's happening here. The 1/2 in front means instead of it going up to 1 and down to -1, it goes up to 1/2 and down to -1/2. And more specifically, if thinking about that chart really helped you from before, here's my parent function. Here's my parent function points I'm using. And now when I stick in front of that a 1/2 times the cubed root of x, I'm just taking each of these and multiplying by 1/2. And then these are my new y values. So again, the shortcut is just instead of going up to 1, go up to whatever the a value is. So this time I went up to 1/2. Alright, I'm ready to do my up, down, left, right shift. So by now, I hope this is becoming kind of automatic for you. I'm thinking right 2, up 4. So right 2, up 4, right 2, up 4, right 2, up 4. Be careful, make sure that that only has that a value of 1/2, and that is my final answer. Domain and range, all reals. If you feel up to the challenge, try part H on your own. Okay, here I go with part H. So again, I'm going to graph my parent function first. This time, my a value is a -1/3. So here's what I want to think about. Instead of going up to 1, I am going to go up to -1/3. Wait a second. Up to a -1/3 means I'm actually shifting it down. So when you have that negative in front, it actually shifts which way the little curve is going. So I took that point and instead of going up to 1, went down to -1, and I put that point in a negative times a negative is a +1/3, so there I go. So it basically rotated it, and it's now only going down to 1/3. Okay, now thinking about this translation, I'm thinking left 1, up 1. So I'm going to take my green graph and go left 1, up 1. Left 1, up 1. Left 1, up 1 for each of the points. Alright, left 1, up 1, left 1, up 1. I'm going to draw in my graph. It's getting a little tight, so I'll just write answer. And then again, domain is all reals. Range is all reals. Please pause and go back and write down anything that you may have missed, and then again, we're going to do a lot of practice of this in class. So thanks for watching, and talk to you soon.